Hi everyone, in this video I'm going to solve Cambridge International AS and A-Level Mathematics Paper 2 Pure Mathematics 2 in a session February-March 2024 Paper 2-2. So let's start with the first question. Question number 1, use logarithms to solve the equation. Give your answer correct to 3 significant figures. Okay, so we have to use a logarithm. So for logarithm, the first step is to apply log on both sides. Alright, so let me apply the log on both sides. Okay, so let me take a log on both sides. Natural log 3 to the power 4x plus 3 equals to natural log 5 to the power 2x plus 7. And applying the power rule of log, power comes before the log. 4x plus 3 is the power which comes before the log natural log of 3, and this power is 2x plus 7. This comes natural log of 5, right? Now we have 4x natural log of 3 plus 3 natural log of 3. This would be equals to 2x natural log of 5 plus 7 natural log of 5. Okay, combine the x terms. 4x natural log of 3 minus 2x natural log of 5, and combine the constant term, which is 7 natural log of 5 and minus 3 natural log of 3. Okay, now we can say, let me take x common. Here we have 4 natural log of 3 minus 2 natural log of 5 equals to 7 natural log of 5 minus 3 natural log of 3. Okay, now we need to solve for x. So x, and we can also take the power rule of log again. So here natural log 3 to the power 4 minus natural log 5 to the power 2 and natural log 5 to the power 7 minus natural log 3 to the power 3. And here we have x. What is natural log 3 to the power 4? 81. So natural log of 81 minus natural log of 5 times 5 is 25. And this is equals to natural log, what is 5 to the power 7, which is 78,125 minus natural log 3 cube is 27. Yes. Okay, so here we have x, and applying the difference property of natural log, here we have 81 divides 25, and this is natural log 78125 divided by 27. Okay, so what this thing, 78125 divides 27 as it is. Okay, 21 divides 25 as it is. Solve for x. So here x would be equals to natural log of 78125 divides 27, everything divided by this natural log of 81 over 25. Okay, so what is the value for x? 78125 divides 27 and natural log of answer, this would be 7.9. We need to figure out the answer up to 3 significant figures, right? 7.97023, 5 decimal place. Okay, 81 divides 25 and natural log of answer is 1.17557. Okay, now we can say 9.7.97023 divided by answer. This is the value for x. X up to 3 significant figures. This is 6.7798, right? So we need to figure out up to 3 significant figures. What is the x value? 1, 2, and 3. This is a third significant figure. It is round up 6.78. This is a value for x. All right. Question number 2, part A. Sketch the graph of y equals to absolute of 3x minus 7, stating the coordinates of the point where the graph meets the x's. Means the x and the y intercept we need to state only, right? So we need to figure out what is x and the y intercept. Start with x intercept. For x-intercept, we need to put the variable y should be equals to 0. When y value equals to 0, what is your x? So absolute of 3x minus 7 equals to 0. Or we can say just 3x minus 7 equals to 0. And here x would be equals to 7 over 3. And 7 by 3 is 2 point something. 2.33. So this is 2.3 recurring, right? Now let me figure out what is the y-intercept. For y-intercept, we have to put the variable x should be equals to 0, right? So when x is equals to 0, y would be equals to absolute of 3 times 0 minus 7. 3 times 0 is just 0. Y value is absolute of negative 7. So the y-intercept is absolute of negative number is a positive number, right? Y-intercept is 7. The x-intercept is 2.3, right? Okay, so let me graph this out. We can say right. We can take this as a middle point. Okay, so the y-intercept is positive 7 for the absolute function, because when you open the absolute with plus minus, right? So one y-intercept is plus 7, the other is minus 7. Okay, this we can say, if I can label this 2, 4, 6, 8, minus 2, minus 4, minus 6, minus 8. This is negative 7. And 2, 4, 6, 8. This is 7. This point and this point. And the x is 2 point something. Okay, this is again 2, 4, 6, 8. Minus 2, minus 4. 2 point some 3 is this point. This is 7 by 3. Right? Now join this point. Or join the x-intercept with this point. This is a shape of the curve. Okay, this is how the absolute function look like, right? Now moving to part B, hence find the set of values of the constant k for which this equation has exactly 2 real roots. Okay, 2 real roots, it means when this absolute function, absolute of 3x minus 7, this function is equals to some linear, this is a linear equation, some straight line, right, which is k x minus 4, right? What is the value of k that when you draw that straight line, you will get 2 solutions, right? It cuts this absolute function at 2 points. Okay, we can do a guess and check method starting with k equals to 0. When the k value is 0, the equation is y equals to 0. So it has one solution. So k is not equals to 0. So check k equals to 1 or at minus 1, 2, minus 2, 3, minus 2. Let's check when they have 2 solutions. So here we have to suppose 2 cases. So the first case we can say let k equals to 0. When the k value is 0, we have the equation y equals to k x minus 4. When the k value is 0, so y equals to 0. And when you draw the graph of y equals to 0, it has only one solution. Here we have one solution. Right. Next we can say let k is equals to 1. When you put k value equals to 1, the equation would be y equals to x minus 4, right? So when x what is 0, the y is equals to negative 4, and when y value is 0, what happened to the x value? When y is 0, the x would be positive 4, right? The x and the y intercept I sort out. So when you put x equals to 0, y is minus 4. And when y equals to 0, x would be equals to positive 4. So when you put 4 and minus 4, x-intercept is 4. This is 2, 4, 6, 8. This is 2, 4, 6, minus 2, minus 4, minus 6, right? So the y is negative 4 and x is positive 4. So it is positive 4 and this is negative 4. And when you connect both of them, so there is no point of intersection, right? So no solution here. We have no solution. Okay. Consider the next case. We can say let k equals to 2. When you put k value equals to 2, then what happened? When k equals to 2, y would be equals to 2x minus 4. 2 into x minus 4. And here y is equals to 2x minus 8, right? And when x is equals to 0, what happened to the y value? Y is equals to negative 8. And when y would be equals to 0, when x is 0, y is minus 8. And when y is 0, x would be equals to, shift the 8 on the other side and divide by 2. 2 times 4 is 8. X is equals to 4. So 4 and minus 8. Okay. So x value is 4 and the y value, this is minus 8, right? When you connect these two, 4 and minus 8, again there is no solution, right? So we have checked with the positive k value 0, 1, 2. Let me check for the negative values of k, right? Here we can say let k is equals to negative 1. So when k value is negative 1, we have the equation y is equals to minus x minus 4, or we can say y equals to minus x and plus 4. Okay, here when x is equals to 0, what happened to y? Y is 4. And when y equals to 0, what happened to x? Here again we have no solution. Sorry, I didn't mention that. Okay, so when the k values are positive, right? 1, 2, 3, up to so on. So for the positive values for k, it has no solution, right? Let me check for the negative values now. When the y value is 0, the x is minus 4 and minus are cancelled out, so x will be equals to 4. X is 4, y is 4, okay? X is 4, the y value is 4. When you draw this line, yeah, you can see it has two solutions. So this line is y equals to with minus x minus 4. Okay, let me check some more solutions. Okay, so here we can say when the k value is negative 2, we can again suppose let k equals to negative 2. When the k is negative 2, what happened to the equation y equals to negative 2 into x minus 4? Y equals to minus 2x and plus 8, right? When x is 0, what happened to y? Here we have two real solutions. Yes, here we have two real solutions when k is minus 1, right? Okay, when x is equals to 0, y is 8. And when y equals to 0, what happened to x? Minus 8. Minus 8 divided by minus 2, x is 4. Okay, x is 4 and y is 8. Look at the graph. X is 4 and the y is 8 over here. This point. X is 4 and the y is 8. If I can draw these two again. Sorry. Join them. Again, they have two solutions. One over here and one over here. So this blue one is y equals to minus 2x minus 4. Okay. I'm extending this red one graph to understand that it has 2 points. Yes, 2 points of intersection. Again, for this we have two real roots, right? So this case, two real solutions. Okay. Now the next is we can say that k equals to negative 3. And the k value is negative 3. What happened to y? Y would be equals to minus 3 into x minus 4. y equals to minus 3x plus 12. When you put x equals to 0, y is 12. And when you put y equals to 0, what happened to x? Y is 0. X is minus 12 over 3. 3 times 4 is 12. X stays a constant 4. And xy value is 12. Okay. If I extend this, right, this point we fix 8, 10, and 12. 12 is over here. This is 12. Okay. And this is 4. So if I connect these two, x and the y intercept, this is the 4 and this is 12. So you can see there is only one point of intersection. When you have this line is for y equals to negative 3 into x minus 4. When you put k value negative 3, you have only one point of intersection. This is only one point of intersection. When you put k value negative 2, it has 2 points of intersection. And when you put k value negative 1, again it has 2 points of intersection. And when k value 0, there is no point, there is only one point of intersection. Yes. Okay, so it is proved that when you put the k value which is 0, it is one point of intersection. K value negative 3, it has one point of intersection. But when the k value is minus 1 and minus 2, it has 2 points of intersection. And when the k values are positive, like 1, 2, 3, there is no solution, right, for positive values of k. So how do we which set of values we have to decide that the k has two real roots? So here we can say the equation absolute of 3x minus 7 equals to k x minus 4 has two real roots when the value of k is between 0 and negative 3. We can say negative 3 is less than k is less than 0. So this is the interval, right? When the k value is negative 3, it has one solution, right? One real root for negative 3. For negative 2, for negative 1, it has two real roots. And for 0, again, it has one real root. And when you put k value 1, 2, 3, and so on, there is no solution, no point of intersection, right? So this is a set of values of k. I hope this is clear now. Question number 3, the polynomial p of x is defined by, we have this polynomial where a is a constant. It is given that 2x minus 1 is a factor of the polynomial. Part A, find the value of a and hence factorize p of x completely. So first we need to figure out a value and then we need to factorize this polynomial. Since we have given that 2x minus 1 is a factor of p of x. If it is a factor of p of x, then when you can do 2x minus 1 equals to 0, so what is the x value? 1 by 2, right? So this implies that polynomial at x equals to 1 by 2 should be equals to 0 when it is a factor, right? So replace x value with 1 by 2 and put it equals to 0. So 6x value is 1 by 2. Its cube plus a, x value is 1 by 2. Its square plus 3, x value is 1 by 2 minus 10 equals to 0, right? Okay, so 1 by 2 cube is, this is 6 and 1 cube is 1, 2 cube is 8. A, 1 square is 1, 2 square is 4 plus 3 by 2 minus 10 equals to 0. Okay, now 6 by 8 we can simplify. 2 times 3 is 6, 2 times 4 is 8 plus 1 by 4 is a coefficient of a plus 3 by 2 and minus 10 equals to 0. Let me simplify the constants. 3 by 4 and then plus 3 by 2 and negative 10. This is minus 31 by 4. So 1 by 4a and minus 31 over 4 equals to 0, right? This is 1 over 4a and this is 31 over 4. Okay, cancel the 4's on both sides, so we got the a value, which is 31. So we have done with the first part, that we need to figure out the value of the constant a. Now in the next part we need to factorize this polynomial completely, right? Now we have the value of a, which is 31. Just substitute the value of a into the polynomial p of x. Now p of x is 6x cube, a value is 31, x square plus 3x minus 10. Okay, now we need to factorize it. For factorization we can use a method of syntactic division, right? So here we can say apply syntactic division method. Okay, so syntactic division method basically reduce the power of the polynomial. So this is a cubic polynomial, it reduce it to quadratic, right? So first of all we need to write down the coefficients of the polynomial, right? Okay, so as we know, the coefficients for this polynomial, x cube coefficient, x square coefficient, x coefficient, and the constant term, right? 6, 31, 3, and 10. Okay, in the question we have given 2x minus 1 is a factor of the polynomial, so we can say x value is 1 by 2. So you can fix x equals to 1 by 2. Right, so bring this first term as it is. 1 by 2 is multiplying with 6. 2 times 3 is 6. We have 3. Add them up. 31 plus 3 would be 34. And 1 by 2 multiply by 34. This would be 17. Over here, 17 add up with 3 is 20. 1 by 2 multiply by 20 is 10. And when 10 and minus 1 add up, it is just 0. Now this is a quadratic polynomial, and it's these are the coefficients of x square, x, and the constant term, right? Okay, now we can write the polynomial p of x as x minus 1 by 2 is the factor, right? 6x square plus 34x plus 20. Okay, we need to factorize it completely. Okay, right. Okay, let me simplify this further. We have 2x minus 1 divided by 2. Let me take 2 common from here. 2 times 3 would be 6. What is 34 by 2? 17. 2 times 17 is 34 and 2 times 10 is 20. You can cancel these 2's. P of x is 2x minus 1. And now this is a quadratic expression. We can factorize this. How do we factorize it? 3 times 10 is 30. Okay. Make the factors of 20 30. 2 times 15 is also 30. And when you do 2 plus 15, this will 17. Okay. Break the midterm. We have 3x square plus 2x plus 15x plus 10. 17 broke into 2 and 15. Now p of x is 2x minus 1 is the one factor. We need to figure out the rest of the two factors, right? So from here we can take x common. 3x plus 2 is left. Okay, and we can take 5 common from here. 5 times 3 is 15 and 5 times 2 is 10. Okay, now in fully completely factorized form, the polynomial p of x is 2x minus 1, 3x plus 2, and x plus 5. These are the three factors, right, for this polynomial p of x. Now for part B, solve the equation polynomial of cosecant theta equals to 0 and theta is between minus 90 to plus 90. Let me write down the polynomial p of x, which is equals to 0. So p of x we have done is 2x minus 1, 3x plus 2, and x plus 5. We can put it equals to 0. When three factors are equals to 0, we have to put them separately equals to 0. 2x minus 1 is 0, or 3x plus 2 would be equals to 0, or x plus 5 would be equals to 0. So from here the x value is 1 by 2. Here the x value is minus 2 by 3, and here the x value is negative 5, right? Now in the equation we have given that polynomial of x is cosecant theta equals to 0. So x is replaced by cosecant theta. Replace these x values with the cosecant theta. We can say cosecant theta is 1 by 2, or we can say cosecant theta is minus 2 by 3, and the third is cosecant theta is minus 5. Cosecant is basically 1 over sine, so we can say 1 over sine theta is 1 by 2. 1 over sine theta is minus 2 by 3, and 1 over sine theta is minus 5. Okay, to get the value of sine, we can do a reciprocal of both sides, right? Reciprocal of both sides. Okay, so here sine theta 1 by 2 reciprocal is 2. Sine theta, the 2 by 3 reciprocal is 3 by 2, and sine theta, this reciprocal is 1 over 5 with a negative, right? This is 2. What is 3 by 2? 3 by 2 is 1.5. 1.5. Okay. This value of sine says sine theta is 2. This value of sine says sine theta is minus 1.5 and 0.2. This value of sine theta says this is minus 0.2, right? So as you can see, range of sine is minus 1 is less than equals to sine theta is less than equals to 1. So when the value of sine is between minus 1 and plus 1, its value is possible, right? So this value is 2. This value is minus 1.5. So from here we have no solution because this does not lies in the range, and we have no solution from this case as well. So we have only solution from here, right? So these two are no solution. Why? Because these values are more than the range. 2 is more than 1, and minus 1.5 is also more than minus 1. So we just need to solve sine theta is minus 0.2 and theta is between minus 90 and plus 90. Okay, let me draw the coordinate diagram and check between minus 90 to plus 90. Okay, all positive, sine positive, tangent is positive, and here cos is positive. Okay, this is 0 and this is 90 degree. We have theta, the base angle. This is from 0 to 90, and this is from 0 to minus 90. 0 till 90, right? So it's base angle, right? And from 0 to negative 90 is negative of the base angle. Okay, so in this case it says sine. First thing, find out the base angle. So the base angle is theta equals to sine inverse of 0.2. This is in degrees, right? Positive. Whenever you're dealing with the base angle, it's always positive, right? Sine inverse 0.2. This is in degree mode, right? 11.5. Theta is 11.5 degrees, right? This is a base angle. So according to this domain, um, minus 90 is less than 90 is less than 90 degree. The sine is negative in, you can see sine theta is negative. According to this domain, sine is negative in, it's positive in the first one, it's negative in the fourth quadrant. So it's fourth quadrant, it is negative. So what is the value for this theta? So this theta is negative of the base angle. Negative of your base angle. So what is a base angle? Base angle is this, theta value is negative 11.5. So this is a solution for theta. I hope this is clear now. This is the only value, 11.5 degrees. Question number 4. The diagram shows the curve with equation. This is equation of the curve. The shaded region is bounded by the curve and the straight lines y equals to x is equals to 0, x is equals to 6 and y equals to 0. Parte, use the trapezium rule. We have to use a trapezium rule with 3 intervals to find an approximation to the area of the shaded region. Give your answer correct to 3 significant figures. All right, let me write down the trapezium rule first. Trapezium rule is basically used to figure out the area under the curve, right? So this area we need to figure out under this curve from 0 to a. So the trapezium rule is area under the curve is half times b minus a divided by n into f of a plus 2 bracket f of a plus h f of a plus 2h up till so on f of a plus n minus 1h and then plus f of b. Okay, f of a, f of b. F of x is basically the function which we have given y equals to f of x, right? A and b are the limits. What are the limits? Limits are from 0 to 6, right? So a value is 0, b value is 6. F of 0 we need to solve, f of 6 we have to solve. Now b and a we have explained that this is b, this is a, and what is n? N is basically the number of intervals. With 3 intervals, so n value is 3, right? And what is h? H value is b minus a over n, right? Okay, and for 3 intervals, you have to solve the first value, right? The middle 3 and this value, right? Okay, so basically total for when the intervals are 3, you have to solve total 4 values, one more, right? So here we can say where h is equals to h value is b minus a over n. This is a value for h. Now, what is a and b? A and b are the limits. A value is 0, the b value 6, 6 minus 0, and are the number of interval which is 3, that is equals to 2. So we have to mention that a and b are limits, n is number of intervals. So in the question we have mentioned that with 3 intervals means the n value is 3. The limits are from 0 to 6, so the a value is 0 and the b value is 6. I hope this is clear why I'm taking a 0, b 6 and n 3. Okay. Now b minus a over n, this value is 2 and these h values are also 2, right? N are the number of intervals, right? Okay. So when the intervals are 3, so in this inside the bracket we have to pick 4 values. The first one, the last one, and the middle, we have 2 more values, right? Okay, now in this case, the area is 1 by 2 into 2 f of a. So we have to figure out what is the function value at 0 plus 2 times, we have to figure out the function value at 0 plus h is 2 plus function value at 0 plus 2 times of h, which is 2, plus the function value at b, which is 6. This is everything we need to solve, right? So this 2 and this 2 is cancel out, so the area we are left with the function value at 0 plus 2 times the function value at 2 plus the function value at 4 plus the function value at 6. Okay, so when there are three intervals, you have to pick the first one, the last one, and in the middle we have only two values, right? So total basically 4. When the intervals are 3, one more value we need to solve, right? When intervals are 4, one more, so 5 values. The first, the last, and the middle values should be more than one, like the middle should be 3, then when then values are 4. Okay, so we have given f of x where y equals to f of x equals to square root of 1 plus e to the power 0.5x. So just replace x with 0, 2, 4, and 6. Now my area is f of 0. F of 0 is square root of 1 plus e to the power 0.5 into 0 plus 2 times f of 2, square root 1 plus e to the power 0.5 into 2 plus square root 1 plus e to the power 0.5 into 4 plus square root 1 plus e to the power 0.5 into 6. Now my area is square root 1 plus e to the power 0 is 1 plus 2 times square root 1 plus e. 0.5 times by 2 is just 1. 1 plus e. 0.5 times by 4 is 2. 1 plus e. 0.5 times by 6 is 3. Let me show you. 0.5 times by 2 is 1. It's times by 3. 0.5 times by 4 is 2. 0.5 times by 6 is 3. Okay. Now this area is e to the power 0 is just 1. 1 plus 1 is 2. This is square root of 2 plus 2 times we have root 1 plus e, root 1 plus e square plus root 1 plus e cube. Let me solve the answer up till three significant figures. Okay, now we have square root of 2 plus 2 bracket square root 1 plus e to the power 1 plus, sorry, 1 plus square root 1 plus e square bracket plus square root 1 plus e cube. 15.65. So this area is 15.655. We need to solve the answer up to three significant figures, right? So up to three significant figures, the area of that shaded region is 15.7 square unit, 6 rounded to 7. That is the area. Now for part B, the shaded region is rotated completely about x-axis. Find the exact volume of the solid produced. Exact volume of the solid is volume of revolution basically. And about x-axis, so Vx we need to figure out, its formula is pi integration from a to b y square and dx. Okay. So we have a and the b, we know Vx would be equals to pi. The a value is 0, the b value is 6, and the y is square root of 1 plus e 0.5 x, its whole square, and dx. Square and the square root is just cancelled out, and we are left with the volume is pi integration from 0 to 6 1 plus e to the power 0.5x dx. Okay. Now let me integrate it. Volume at x would be equals to pi, and the integration x integration, one integration is x plus e to the power 0.5x, and the derivative is 0.5, and the limits are from 0 to 6. Okay, let me substitute the limits. Vx, pi is outside, we can do the upper limit, which is 6 plus 0 e to the power 0.5 into 6 divide 0.5. This is upper limit. Subtract the lower limit, x is 0 plus e to the power 0.5 into 0 divided by 0.5. This is a lower limit. Okay, so the volume is pi is outside. Here we have 6 plus, okay, we have 1 over 0.5, which is 2. 0.5 times by 6 e cube, and 0, and this is minus 2. E to the power 0 is just 1. E to the power 0, this is just 1. Vx is pi is outside. Here we have 4 plus 2 e to the power cube. This is the exact volume, because we need to just figure out the answer, exact answer, right? So this is the volume in terms of pi and e. Question number 5. The diagram shows the part of the curve with the equation. This is the equation of the curve, and some part is shown. At point P, the gradient of the curve is 6. At point P, the gradient of this curve is equals to 6. Part A, show that the x coordinate of P satisfies this equation. Okay. Okay, so in the question we have given that the gradient of the curve dy over dx at P some xy, this should be equals to 6. At point P, this is 6, right? So we need to figure out what is dy by dx here. Dy over dx, here we need to apply the quotient rule, right? The denominator function, derivative of the numerator function is 3x square minus the numerator function, derivative of the denominator function divides the denominator function square, x plus 2 whole square. Okay, let me do one more step. Dy over dx is 3x square multiplying with x would be cube. 3 times 2 would be 6x square minus x cube divides x plus 2 whole square. Okay, and here dy over dx is 2x cube plus 6x square divides x plus 2 whole square. Okay, now what we have given that the gradient at point P, this is a gradient at point P, this is equals to 6. We have to solve for the prove that the x coordinate of point P satisfies this equation. All right, so we need to cross multiply 2x cube plus 6x square. This would be 6 times x plus 2 whole square. Open the square. 2x cube plus 6x square, this would be equals to 6 is outside. We have x square plus 4x plus 4. Okay, further simplification, 2x cube plus 6x square would be equals to 6x square. 6 times 4, 24x plus 6 times 4 is 24. Shift all the terms to the left side. 2x cube plus 6x square minus 6x square minus 24x minus 24 equals to 0. So positive and negative, this is cancelled out. Okay, so we are left with 2x cube minus 24x minus 24 equals to 0. Right. If I compare this, we have 12x plus 12 and the cube root over here. Okay, use this comparison and figure out the x value. If I can say 2x cube is over here and shift 24x and plus 24 on the other side, we can take 2 common, x cube is left, and here 2 common, we are left with 12x plus 12, right? Now 2 and 2 both are cancelled out. Here we have x cube is equals to 12x plus 12. And what is the value for x? X is a cube root of 12x plus 12. It is proved that the x coordinate of P satisfies this equation. Now for part B, show by calculation that the x coordinate of P lies between 3.8 and 4.0. If x coordinate lies between these 2 points, then there must be a sign change, right? So we know that the x coordinate of P is x is equals to cube root of 12x plus 12. This is x coordinate of P, right? So we have to use the sign change. Okay. Now for sign change, we have the function f of x. We have to make a function f of x which is cube root of 12x plus 12 and shift this x on the other side minus x, right? Now we have to check what is that function value at 3.8, okay, and what is the function value at 4.0. So cube root of 12 into 3.8 plus 12 and minus 3.8, or cube root of 12 into 4 plus 12. 4.0 is 4 and minus 4. Let me check. If there is a sign change, then the root must lies between these 2 points, okay? All right, so cube root 12 times 3.8 plus 12 and minus 3.8. This value is 0.0. 0.062, and the other value is 4. This is with negative 0.085. So one is positive, the other one is negative, so there is a sign change, right? So we can say since there is a sign change, this implies x coordinate of P lies between 3.8 and 4.0, right? Part C, use an iterative formula based on the equation in part A. Find the x-coordinate of P correct to 3 significant figures. Show the result of each iteration up to 5 significant figures. Let me write down the iterative formula. Iterative formula is based on part A. Part A is x is equals to cube root of 12x plus 12. Okay, iterative formula, this subscript is n plus 1, this subscript is n, and we need the initial guess. Initial guess, as we have done in part B, that there is x coordinate of P must lies between 3.8 and 4. So we can say the initial guess must lies between them. We can pick x 3.9, right? And now start the iterations, right? N is equals to 0. When n value is 0, we have x1, which is root 12 root cube root x0 plus 12. X0 is 3.9, right? So we have to check cube root 12 times 3.9 and plus 12. 3.3 up till 5 significant figure, right? Each iteration is 5 significant figure, 1, 2, 3, 4, and 5 significant figure. This rounded to 6, 3.886. Right. Now when n value is 1, when n equals to 1, x2, because 1 plus 1 is 2, this is cube root 12x1 plus 12. So what is x1? This is x1, the answer. Okay, 1, 2, 3, 4, 5. Just rounded to 6, 3.8856. Okay, the next iteration when n value is 2, x3 cube root 12x2 plus 12. x2 is this value, the answer. 3.887848, sorry, this rounded to 8. 3.8848. Okay, so as you guys can see, if we respond exceed it further, so the x coordinate of p up to 3 significant figure, 3.88, 3.88, 3.88. So this is 3.88. This would be the x coordinate of p, approximately up to 3 significant figures. Question number 6. The diagram shows the curve with a parametric equation x in terms of t and y in terms of t. For t is between 0 to 25. The curve crosses the x-axis at points A and B and has a minimum point M. A and B are the point where the curve crossed the x-axis and the minimum point is M. Part A show that dy by dx in terms of t. Okay, so we can easily find dy by dx. As you can see, x is a function of t, y is a function of t, so we have to apply the chain rule. Right? Since we have given x is equals to 1 plus square root of t, right? We have to differentiate it. Dx over dt is 1 derivative is 0, square root of t is 1 half. First write down the power, then the base, then power minus 1, and the derivative d by dt of t is just 1. So here we have 1 over 2, t to the power 1 by 2 minus 1 is minus 1 by 2. So 1 over 2, and we have a square root of t, yes, in the denominator. Now the second y function we have given is natural log of t plus 2 into natural log of t minus 3. Again, to differentiate this y function, we have to apply the chain rule, right? So the chain rule is dy over, the product rule. The first function is as it is, derivative of the second function, natural log of t minus 3, plus the second function is as it is, derivative of the first function. Let me simplify. Dy over dt, natural log of t plus 2, ln of t derivative is 1 over t minus 3 derivative is 0, plus natural log of t minus 3, ln of t derivative is 1 over t, and 2 derivative is a constant which is just 0, right? For this simplification, dy over dt, we can say we have 1 over t. Let me take it common. We are left with natural log of t plus 2 plus natural log of t minus 3. Okay. Now dy over dt becomes 1 over t. There is 2 times natural log of t and minus 1. Okay, now we have to apply the chain rule. By the chain rule, dy over dx, this becomes dy over dt and dt over dx. Y with respect to x, y with respect to x, and we have some dt. We have dy over dt, which is this 1 over t, 2 natural log of t minus 1. Multiply dt over dx. We have dx over dt. Dt over dx would be the reciprocal, which is 2 square root of t. This is 2 square root of t. We have to prove that it is in this form, which is okay. All right. Now here we can say 1 over t and square root of t. This term and this term. So 2 is multiplying with 2 natural log of t and minus 1. So 2 times 2 would be 4 natural log of t, and 2 times 1 is minus 2. Okay. All right. So here we have 1 over t. This t power is 1 and this t power is 1 by 2. Here we have 4 natural log of t minus 2. So we have done with 4 natural log of t minus 2. So shift this power to the denominator. So 1 over t power is 1 and here t power is minus 1 by 2. 4 and n of t minus 2. And when the bases are same, we can add up the powers. 1 minus 1 by 2 is 1 by 2. 4 ln t minus 2. So here we have dy over dx is 4 natural log of t minus 2 divides square root of t. So it is proved that we can write the derivative in this form. You need to show that. Now for part B, find the exact gradient of the curve at B. So exact gradient of the curve, we have to find dy over dx at point B. Okay, so at B, find dy over dx, right? So for this, we need to figure out the point B, right? For point B, what we have to do, as you can see in the question, that the curve crosses x-axis at point A and B, right? So when curve cross x-axis, y is equals to 0. So in the curve, just substitute y equals to 0 and solve for the value. So here is the curve. When you put y value equals to 0, you can get the t value, right? So y is equals to ln t plus 2 into ln t minus 3. When y is equals to 0, natural log of t plus 2 into natural log of t minus 3. Two factors are 0, means we have to put both of them separately. Equals to 0, natural log of t plus 2 equals to 0, and ln t minus 3 equals to 0. Here we can say natural log of t is equals to minus 2, right? And what is t? T is equals to e to the power minus 2. Here natural log of t is equals to 3, and here t value is e to the power 3. Okay. Now we have two values of t, e to the power minus 2 or e to the power 3. So for coordinates of b, so b coordinates, there is some x value and the y value is 0, right? So when you substitute the t coordinates over here and get the x coordinate, right? So we can say put t values in x equation. Okay. So the x equation is x is equals to 1 plus square root of t. Then we can easily guess that which x coordinate is for A and which one is for B. So x is equals to 1 plus root e to the power minus 2, and x is equals to 1 plus root e to the power 3. I substituted both of them. t is e power minus 2 and t is e power 3. Okay, let me check. 1 plus root e to the power negative 2, 1.3679 up to 4 significant figures, 4 decimal place, and 1 plus root e, sorry, 1 sorry, 1 plus root e cube, 5.4817. Okay, which one is the x coordinate for A and which one is for B? Now look at the curve. The curve says the A comes first and then we have B. So the A x coordinate, this is a coordinate for A, 1.3. This is for A, and this for the point B, right? 5.5 and 1.4. So the x coordinate of A is 1.4 and the y is, this is 5.5. This is 1.4, 1.4 and 5.5, right? Now we have the coordinates of B. So we can write down the coordinates of B are coordinates of B. The x coordinate is 5.482 and the y coordinate is 0. Now we can find the exact gradient of the curve at point B. So for point B, what is the t value? The t value is e cube, right? Now we have the gradient of this curve. Gradient of the curve is this at point B. The B is basically the substitute t value is e cube, and you can easily get the exact value for the coordinate of B, exact value of the curve at point B. Now this is dy over dx, and this is in terms of t. So we have to figure out what is dy by dx at t equals to e cube. Okay, and 4 natural log e cube minus 2 divides cube square root of e cube. We need to figure out the exact one, right? And this is 4. We have 3 and natural log of e. 4 is as it is. Power comes before natural log 3 and natural log of e minus 2 divides e to the power 3 by 2, because this whole power is 1 by 2, right? Equals to, now dy over dx at t equals to e cube, this is 12 minus 2 over e power 3 by 2, because natural log of e is 1, 3 times 4 is 12, this is 1 and then minus 2. So the exact value is gradient is 10 minus 2 is 12 minus 2 is 10 and e to the power minus 3 by 2. When you shift this power to the numerator, it becomes negative. This is the exact value of the gradient of the curve at point B. Now for part C, find the exact coordinates of M. So in the question, what is M? M is the minimum point of the curve. This is a minimum point of this curve. And we know that for minimum point, you have to put first derivative equals to 0. Right? Since M is the minimum point, so for minimum point, you have to put the first derivative dy over dx is equals to 0. Now the first derivative is 4 natural log of t minus 2 divides square root of t. This is equals to 0. Now here we have to solve for t. 4 natural log of t minus 2 would be equals to 0. 4 natural log of t would be equals to 2. Natural log of t is equals to 2 by 4, which is 2 times 1 is 2, 2 times 2 is 4. And what is t? T would be equals to e to the power 1 by 2. This is a value for t. Okay, when the t value is this, we need to just solve for the x and the y coordinates, right? So in the curve, just put x t value in x and in y, we will get the coordinates, right? Now the x coordinate is 1 plus root t. This is 1 plus root t is e to the power 1 by 2, right? And here we have 1 plus e to the power 1 by 2, and its whole power is also 1 by 2. So this is 1 plus e to the power 1 by 4. This is x coordinate. Okay. Now for the y coordinate, we have ln t plus 2 into ln t is e power 1 by 2 and minus 3. This is a y coordinate. So again, y is equals to power comes before the log 1 by 2, natural log of e plus 2, 1 by 2, natural log of e and minus 3. Natural log of e is just 1, so y is equals to 1 by 2 plus 2, and here 1 by 2 minus 3, and we will do the product. Okay, 1 by 2 plus 2 is 5 by 2. Y is equals to 5 by 2, and 1 by 2 minus 3 is minus 5 by 2. So the y value is negative 5 times 5 is 25, 2 times 2 is 4. Okay, so we can say the exact coordinates of M are x coordinates are 1 plus e to the power 1 by 2, 1 by 4, sorry. And the y coordinates are minus 25 divided by 4. These are the exact coordinates of M. Question number 7, part A, proves that the left hand side is always equals to the right hand side where A and B are the constants. So let me start from the left hand side. Okay, so we have sine 2 theta into A cot theta plus B tangent theta. Sine 2 theta has a formula to sine theta, cos theta, double angle formula. Cot is basically cos over sine, cos theta over sine theta. And tangent is a ratio of sine over cos, sine theta over cos theta. Okay. So here we can simplify the bracket first. 2 sine theta, cos theta is as it is. A cos theta and opposite denominator cos square theta plus b, we have sine theta, multiply with the opposite denominators with sine square, divides sine theta cos theta. Okay, so now this sine theta cos theta is cancelled out, and we are left with 2 a cos square theta plus b sine square theta. Okay, how can I make this as cos 2 theta? Okay, here we have to make the formula of cos 2 theta. So cos 2 theta has three formulas. Cos 2 theta is equals to 2 cos square theta minus 1, and cos 2 theta is also equals to 1 minus 2 sine square theta. The third one I'm not writing down because in this we have cos square and we have sine square. So these two formulas we have to make. So in this equation, if I can say 2 is outside, a cos square theta. So let me add and subtract a, and let me add and subtract b plus b cos sine square theta. I just add and subtract a and b, right? If you can cancel out, you will get the same thing. Okay, so 2 is outside. So if I can take a common from these two, cos square theta, wait a second, before adding and subtracting b, I would like to open this 2. So we have 2a cos square theta plus 2b sine square theta. So 2a cos square, 2b sine square is as it is, just plus minus a plus minus b. Now we can take a common from here. When a is common, we are left with 2 cos square theta minus 1 plus this a is as it is, right? And with b, we can say plus b is also as it is, and taking negative b is common, we are just we are left with, when negative b is common, 1 is left, minus 2 sine square theta. Now this is cos 2 theta, and this value is also cos 2 theta, right? So we have a cos 2 theta plus a plus b minus b cos 2 theta. Okay, so we can write this as a plus b. First write down this, right? And then we have a minus b. This is a and this is b, and common is cos 2 theta. Now this is your right hand side. It is proved. A plus b plus a into a minus b cos 2 theta. So the main concept over here is just open the formula of sine 2 theta, open cot, tangent, and then you have simplify, you got this, right? Now you have to use the, since we have to make cos 2 theta double angle formula for cosine, right? So write down all the double angle formulas of cosine, but we need only two formulas, which involves cos square and sine square. So these two formulas, and open after distributing the two inside the bracket, we have done with this. Now we have some a and b with the plus and the minus sign, so it is better to add and subtract a and b, right? And then you can easily make cos 2 theta and you will get your solution. Now for part b, find the exact value of the integral sine 2 theta 5 cot theta 3 tangent theta d theta. Okay, so we know that sine 2 theta into a cot theta plus b tangent theta, this is always equals to a plus b plus a minus b cos 2 theta, right? Now if I make a comparison, we have sine 2 theta 5 cot theta plus 3 tan theta. So what does that mean? This means that the a value is 5 and the b value is 3, right? This is always equals to a is 5, b value is 3, plus a value is 5, b value is 3 cos 2 theta. Or this is always equals to 5 plus 3, 5, 6, 7, 8 plus 2 cos 2 theta. Okay. Now we can integrate it. This term is equals to this. Now we can do the integration from pi over 12 to pi by 6 of 8 plus 2 cos 2 theta and d theta. So 8 integration is 8 theta. 2 is a constant term. Cos integration is sine 2 theta, and 2 theta derivative is just 2, and apply the limits from pi by 12 till pi by 6. So this 2 and 2 is cancelled out. We are left with 8 theta plus sine 2 theta. The limits are from pi by 12 till pi by 6. Now we can apply the limits, right? Apply limits. The upper limit is pi by 6 and the lower limit is pi by 12. Okay, so 8 upper limit is pi by 6 plus sine 2 into pi by 6. This is your upper limit. Subtract the lower limit is 8 times pi by 12 plus sine 2 pi by 12. Alright. So 2 times 4 is 8, 2 times 3 is 6. Sine pi over 2 times 3 is 6. 2 times 4 is 8, 2 times 6 is 12 plus sine pi over 2 times 6 is 12, pi by 6. Pi by 4 pi by 3 plus sine pi by 3. Okay, in radians. Sine pi by 3. Root 3 by 2. The exact value we need to figure out, right? Because in the question it says the exact value of this integral. Okay. Square root of 3 divided by 2. This is minus 4 times 1. Okay. 2 times 2 is 4. 2 times 3 is 6. And minus pi by 6. 1 by 2. I opened the bracket. This minus and this is also minus. Okay. So there are two values with pi. 4 pi by 3, 2 pi by 3. So 4 pi by 3 minus 2 pi by 3 plus square root of 3 by 2 minus 1 by 2. Okay, so 4 pi minus 2 pi divided by 3 plus root 3 minus 1 divided by 2. So this would be 2 pi over 3 plus square root of 3 minus 1 divided by 2. So this would be the exact value of the integral. Now for part C, solve the equation equals to 11 and alpha is between minus pi to plus pi. Okay, so given that sine 2 theta a cot theta plus b tangent theta, this is always equals to a plus b plus a minus b into cos 2 theta. Okay, let's make a comparison. Okay, 2 theta is alpha by 2, alpha by 3. Sine 2 is as it is and alpha by 3 is your theta. A value is 2, theta is alpha by 3, b value is 7. Okay, here we have sine 2 and the alpha value, theta is alpha by 3. A value is 2 cot alpha by 3. B value is 7. Tangent theta is alpha by 3. Okay, so now we come to know that theta is alpha by 3, A value is 2 and the B value is 7. Okay, this is always equals to A is 2, B is 7. A is 2, B is 7. Cos 2 theta is alpha by 3. Okay, now we can say this is 7, 8, 9, 9 minus 5 cos 2 alpha over 3. This is equals to 11. This whole thing is 7 plus 2 is 9 and 2 minus 7 is minus 5 and this is 2 alpha by 3 and put this equals to 11 and now we have to simplify. Minus 5 cos 2 alpha divided by 3 would be equals to 11 minus 9 cos 2 alpha over 3 would be equals to 11. Take away 9, 9 and 11, 2. 2 divides minus 5. This makes cos is negative, right? Okay, so cos of 2 alpha over 3, this is your angle now. This would be equals to 2 by 5 is 0.4. It's negative of 0.4. So cos 0.4, this value is in the range between -1 and +1, right? Now cos is negative and the domain we have given is from minus pi to plus pi, and check cos is negative in which quadrant, right? Let me draw the coordinate diagram first. Okay, here all trigonometric ratios are positive, sine is positive, tangent is positive, and cos is positive, right? Now this direction is from 0 to pi, and this direction is from 0 to minus pi, right? So this is from minus pi till 0 and then 0 to pi. So this is from 0 to pi and this is from 0 to minus pi. So in the first quadrant we have the base angle, and here we do pi minus base angle, and here we do minus pi and minus of pi minus base angle, or we can say minus pi plus the base angle, the opposite, right? So this is a anti-clockwise direction, this is a clockwise direction. If this is theta, this is minus theta. If this is pi minus theta, this is pi minus pi plus theta, right? Okay, now we can find out the base angle first. Now for the base angle, 2 alpha over 3, this would be equals to cos inverse of 0.4. This is in radians, right? Your calculator should be in radians, right? Cos inverse 0.4 is 1.1592. 2 alpha over 3, this is 1.15928. Okay, now we know that according to the given domain, right? According to the domain that minus pi is less than alpha is less than alpha, we know that cos is negative in, okay, in which quadrant cos is negative? Cos is positive in the first quadrant, and in the fourth it is negative in second and third quadrant. It is negative in second and third quadrant. Now what is the value for the second quadrant? For second quadrant, the angle, this is the angle, this is equals to pi minus the base angle, pi minus the base angle, and let me solve for alpha. Okay, so 2 over 3 into pi minus this angle. Pi minus this angle, multiply by 3 and divided by 2. Okay, now pi minus that angle, multiply 3 by 2, 2.97. Alpha is 2.97. This is the value for alpha, right? One solution. And it is also negative in third quadrant. So what is angle? This is for the second quadrant. Now we are dealing with the third quadrant. Now for the third quadrant, the angle 2 alpha over 3, this would be equals to minus pi plus this base angle, 1.15928. So what is alpha? Alpha is 3 by 2 into minus pi plus 1.15928. Okay. 1.15928 minus pi multiply 3 by 2 is minus 2.97. This is your second solution. So these two values of alpha are in the range from minus pi to plus pi. Alright, that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.